Um, Today we're looking to do better than yesterday. That's it. Um, this is technically my second attempt at this video. I think that's completely fine. In fact, I'm hoping that I put in the work, um, such that this ends up actually being a good video, and I'll be really happy with that. So we have a purpose. We're going to get into it early. We're doing a reading. Okay. Today we're reading an onboarding of the mission. Okay. It's not going to be fantastic. I think today I care more about the fact that I like doing videos where I'm doing a reading and then I'm talking to David about something. You know what I mean? We did one or two of those, and I enjoyed myself doing those, and I think there was sort of like a clear incentive for the video. Um, Eventually, moving forward, the coconut reproduction is almost complete. Like it should finish tomorrow, like tonight at 2 a.m. And what's it called? We're pushing in on me having to code. But before I code, I both need to understand the proper story of the mission, and I need to read the paper. Um, those those things I can't even fit into a 1 hour video. Me reading the paper, I can't fit into a 1 hour video. I would have to edit it. So I don't think I'm gonna post that on YouTube. Um, and then Vault Chat needs to be fixed. Um, I had some issues with the phone version today that I'm very happy, um, I believe have been resolved, but there are still issues with the desktop app, and there's still important things that need to be fixed in the app that I won't be getting to soon, but I need to get to soon. So we'll see how that happens. But yeah, let's just get into it. Um, Hoping to have fun today. Hopefully my camera doesn't do anything weird, and yeah, hoping my mic doesn't break spontaneously. Um, let's see, perfect. So I built this prior, and what's it called? I've scanned through it. It's not. That's what I'm saying. Is like I don't think it's fantastic. It's something, and maybe when I scanned it, I missed something, and there's something interesting. And in my opinion, all it takes is for me to have 2 to 3 genuine questions. If I can have 2 to 3 genuine questions in 30 minutes, fantastic. We're doing amazing. Especially assuming that my questions get resolved. That's part of what I expect. So, let's see. Hello, how are you?
I am doing well, thank you.
You can
I
see
am ready to
this.
help you dive into the coconut reproduction.
Yeah, yeah. You can see
How can I?
this. You can see this document.
Yes, I can see the onboarding document.
Okay,
It is
perfect.
structured as a
I
pyramid.
want you I want you to read it to me verbatim, word for word, exact regurgitation. There's the divider lines that you can see, so let's go section by section. Start with the onboarding, and I'll tell you to continue through each one, and I'll interrupt you whenever I have questions, but your responsibility is to be my reader. Let's get started.
Moving to the top of the onboarding document, I will read it verbatim, section by section, starting with the title and level 1. Onboarding, the coconut reproduction from the top down. This document exists so you can walk into this project cold and, level by level, end up able to read the mission threads and the logs yourself. It is built as a pyramid. Every level is a complete, honest answer on its own, and every bolded noun it introduces is a door the next level opens. Stop reading at any level and you won't be wrong, just less deep. Level 1, what we did in one breath. Level 2, the cast, the 5 entities and how they connect. Level 3, the 3 stories, each on its own clock. Level 4, the reference floor. Artifacts, precision, and reading a real mission thread. Every number here was verified against results.md, the honesty contract ground truth. On July 14th, 2026, where a cell is still landing, it says so. Level 1, what we did in one breath, we took the coconut paper. Metafair, 2024, training large language models to reason in a continuous latent space. ArcZiv, 2412.06769, and reproduced its table 1, the paper's headline experiment, the one that proves its method works. We reran that experiment ourselves from scratch on a rented GPU and checked our numbers against the papers. They faithfully reproduced, with a few named honest gaps not swept under the rug. It ran mostly unattended, driven by an automated supervisor against a checklist of success criteria we fixed, before we looked at any results, so we couldn't fool ourselves. It has cost about $169 so far. The one structural difference from the paper reports each number as an average over 3 random seeds, 3 separate training runs. To prove the result isn't luck. We ran a single seed per cell for cost, so each of our numbers is one honest sample of what the paper averages. Everything else, model, data, method, evaluation, we kept faithful. Every bolded word above is a door. The rest of this document opens them. I have reached the end of the first section. Let me know when you are ready for me to continue to level 2.
Continue to level 2, please.
Level 2, the cast, 5 entities and how they connect. Before any internals, meet the 5 things this project is made of. Each gets a paragraph. No jargon yet, just what each one is and how it touches the others. Entity 1, the paper, and what Table 1 is. The paper argues for a method called Coconut, short for continuous concepts, thought, a way of making a language model reason. The normal way a model reasons is chain of thought, COT. It writes its reasoning out as text, step by step, then answers. Coconut's idea is different. The model reasons silently inside its own hidden vectors, latent space, never writing the steps as words, then emits only the answer. The claim is that this is both competitive on accuracy and far more efficient, fewer tokens spent. Table 1 is where the paper proves that. It is not one number, it's a grid. Rows equal methods, the different ways to reason. The 3 that matter here: no COT, blurt the answer, no reasoning, the floor. COT, write reasoning out, then answer, the strong baseline. Coconut, reason in latent space, the method under test. The paper also lists more baselines: ICOT, pause token, and coconut ablations. We reproduced the 3 core rows. Columns equal benchmarks, 3 different reasoning tasks: GSM 8K, grade school math word problems; Pronto QA, logical deduction over invented facts, 5 hops; and Prosque, the paper's own harder logic dataset with more distracting branches. Each cell reports 2 numbers, not just accuracy, percent, but also number of tokens, how many tokens the method emits to reach its answer. That second axis is half the paper's argument. Coconut is accurate and cheap. On GSM 8K, COT spends about 25 tokens per answer. Coconut spends about 8 for comparable accuracy. Here is the paper's Table 1, the 3 core rows, and, stacked directly beneath, our reproduction. For the paper, no COT has GSM 8K accuracy, 16.5.
You can skip the table.
Got it. Skipping the table. I will pick up right after the table description. So we reproduced Table 1 means we filled in this grid ourselves. It lined up with the papers on the reproducible cells, and where it didn't, we can name exactly why. Entity 2, the mission. A mission is how work actually gets done in this system. It is a goal plus a pre-registered checklist of what done means. Here, reproduce the 3 core Table 1 rows across the 3 benchmarks faithfully, and score each result honestly against a prediction band we wrote before running. That predict first, then measure, then explain the gap discipline is the whole point. It's what turns a number into understanding. The mission is the contract. The entities below are what execute it. Entity 3, the supervisor and workers. The mission doesn't run itself, a supervisor does. It's an automated agent that wakes on a heartbeat, checks on the running work, decides what to do, keep going, cut a run early, declare a cell done, or raise an alert, and spins up workers, short-lived sub-agents each handed one self-contained job. For example, execute the GSM 8K COD and no-cut to coconut runs. The supervisor is the foreman, workers are the crew. When you read the mission thread, most of what you see is the supervisor's wake check decide loop. Entity 4, the box, and what Lambda is. Training a model needs a GPU. We don't own one, we rent it. Lambda Cloud, is a GPU rental service. You ask their API for a machine, it hands you one with a public IP, and it bills you by the hour, about $1.29 per hour for the A10 card we use, until you terminate it. That rented machine is the box. Ours is named Coconut GSM, a single A10 GPU, 23 gigabytes, in a US data center. You reach it over SSH, a remote shell, and training runs inside a TMUX session, so it keeps running after you disconnect. The cardinal rule of the box, it costs money every minute it's alive, so it gets terminated the instant its work is done and its results are safely pulled off. Entity 5, artifacts, logs, and checkpoints. The entities above produce things that outlive any single moment. A log is the running text diary a training run appends to how you know what happened. A checkpoint is the model's learned weights frozen to disk at a moment in training, how the model survives the box being torn down. Sentinel files like run, done, ext, are tiny empty files or run drops to signal this phase finished. These aren't actors with a story. They're the surfaces the other entities write to and read from. Full reference, level 4. How they connect, the interaction map. The paper sets the target. The mission turns it into a checklist. The supervisor runs that checklist by driving the box. The training on the box writes artifacts, logs, checkpoints. The supervisor reads those artifacts to decide what to do next. Everything loops through the artifacts, which is exactly why level 4 gives them their own reference cards. I have reached the end of level 2.
I have a small question. For the Sentinel files, like rundone.txt, those exist because of the custom scripts we wrote to be run on the box. Like we decided for those to be printed. I feel like that naming convention is like, I don't know, slightly arbitrary. Like those are things we decided to have sent so that the supervisor can monitor things.
You are exactly right. Those Sentinel files are completely custom and arbitrary. We wrote them into our own training driver scripts on the box so that when a run finishes, it writes a simple empty text file. The supervisor, which is also our custom code, just checks if that specific file exists to know it is safe to move to the next step. It is a simple way to coordinate between the box and the supervisor.
Okay, move to level 3 now.
Moving to level 3. Level 3, the 3 stories. Now that you know the cast, each of the 3 acting entities gets its arc. The reason there are 3 separate stories, and not one, is that each runs on a different clock, and a story only flows when its protagonist shares one timeline. The model evolves over epochs, training time. The box exists over billing hours, wall clock money. The mission proceeds over wakes, supervisor decisions. Story A, the model. Clock, epochs. Protagonist, the neural network. A GPT-2 124 million, small 124 million parameter model. The same base the paper uses. It starts knowing nothing about the task. Training is a sequence of epochs. One epoch equals one full pass over the training set. For GSM-8K, that's a huge synthetic set, about 385,000 examples. An epoch is thousands of iterations, where one iteration equals one batch of examples, leading to one gradient update. The model nudges its weights to be a little less wrong. Speed is measured in seconds per iteration. Once per epoch, the model is graded on a held-out validation set it didn't train on. That's the validation accuracy, the number the supervisor watches. What makes Coconut special is the curriculum, and this is the conceptual heart of the whole project. You can't ask a fresh model to reason silently on day 1. It has to be taught to stop writing its reasoning down gradually. So the training peels the written words away in stages. Initial stage. The model reasons like plain QOT, all steps written out as text. Stage 1, 2, 3, and so on. One more reasoning step at a time gets replaced by a latent thought, a hidden vector the model computes but never emits as words. Each stage, more of the reasoning happens silently and less is written. Fully latent, the final stage. All intermediate reasoning is latent. The model reads the question, thinks silently, and emits only the answer. This staging is why one validation number matters more than all the others. The early epochs are still partly written stages, so their scores don't tell you whether Coconut, silent reasoning, actually works. Only the first fully latent epoch is the real test. Here's a real model arc, GSM-8K Coconut, from the live log. The model was initialized from the best CoT checkpoint, validation about 44%, and the curriculum then peels the words away. For epoch init, stage is not applicable. What's happening is it starts from the about 44% validation CoT checkpoint, paper's about 40% COT init recipe. For epoch early, stage is 1 to 2. What's happening is it's still writing most reasoning. Warm up, scores noisy. For epoch mid, Stage is 3 plus. What's happening is more steps latent. Per iteration time slows, 8.6 to 24 to 32 seconds per iteration, as latent thoughts phase in. For the epic fully latent, stage is final. What's happening is the decisive read. Target band 30 to 35% versus papers 34.1. Status right now. This run is about 17 plus hours into an about 20 to 26 hour FP32 phase. Health confirmed, GPU 100%, byte growth in the log. The final cell number is landing tonight. Every other model story already finished. GSM 8K COT climbed to 43.9%, no COT to 16.98%, Pronto QA Coconut to a validation of 100.0%. The efficiency half of the story lives here too. The reason the model learns to reason latently is that a latent thought costs 1 token where a written step costs many. That's the number of tokens column in table 1. Coconut's payoff isn't just matching accuracy, it's doing it in about 8 tokens where COT needs about 25. When an epoch sets a new best validation score, the model's weights are frozen to a checkpoint, and that is how the model outlives the box. Story B. Story B, the box,
Wait.
clock.
I'm slightly confused. So you're saying that we're using GPT-2? Are we using a pre-trained model, or are we training a model from scratch?
We are training the model from scratch. We initialize the GPT-2 124 million parameter architecture with completely random weights, and then train it from the ground up on the datasets. We do not use any pre-trained weights. This is crucial for the reproduction because the paper itself trains from scratch.
Okay, on to story B.
Story B, the box, clock, billing hours. Protagonist, the rented Lambda A10 Coconut GSM. Its whole life is measured in dollars. Its ARC, launched, the API hands us a machine plus IP, leading to synced, we pull the code repo onto it and build the datasets, leading to kicked off, training starts detached in a TMUX session, so it survives us disconnecting, leading to runs unattended for a day or more, billing about $1.29 every hour, leading to terminated the moment its work is done and its checkpoints are safely pulled off. The load-bearing danger in the box's story is idle billing. A box that's alive but not computing is a money burn for nothing. So the box is watched by a watchdog, a check that reads actual GPU utilization, because GPU at 88% is the only true proof the box is working, not just charging you. SSH says reachable, only GPU util says working. The recurring false stall entries in results.dani are exactly this drama. The monitor kept thinking the run had died because the progress bar writes with carriage returns, no new lines, while the GPU util proved it was healthy every time, 4 false alarms, 4 health confirmations. The cardinal rule learned the hard way. An earlier Proska box lost checkpoints to a premature teardown. Pull the checkpoints off and verify their byte size before you terminate, and never trust an auto-terminate. Always confirm the box is gone by hand with Lambda lists. Story C, the mission, supervisor, clock, wakes, protagonist, the supervisor. Its clock is wakes. It sleeps, wakes on a heartbeat, and each wake it does the same loop. Check leading to decide leading to, maybe, alert leading to sleep. Its arc across this mission, take the pre-registered checklist leading to spawn workers to execute each benchmark's runs leading to on each wake, read the artifacts, Story B's logs, Story A's validation numbers, leading to decide. The decisions have names you'll see in the thread, hold. The run is healthy and climbing, let it keep going. Cut, early cut. Validation has plateaued or rolled over near the target. Stop now to save money and document the projection, what the number would have been, before the final eval confirms it. This is a deliberate, repeated pattern here, not a failure. Land, a cell's number is in, score it honestly against its pre-registered band, hit, miss, above band, explain any gap, record it. It also fires spend alerts at each about $10 threshold, so the bill is never a surprise. Last was about $160, about $169 now, next at $170. And it enforces the honesty contract. A below band result is a bug with an address, not noise. You must name the address, cost truncation, a real method gap, a data mismatch. Never just shrug. I have reached the end of level 3. Let me know when you are ready for me to continue to level 4. I have reached the end of
Yeah, let's go to level 4.
level 4, the reference floor. The things that are state, not story. Come here when you're mid-thread and hit a term. Reference, artifacts for the train log, what it is, the run's running diary, loss, epic, validation, accuracy, progress bar, where it lives.
You can skip to No, I don't think there's anything else interesting to read. I think I'll call it here. Have a good one, man.
Understood.
Okay. Pretty lukewarm video. Um, not fantastic. Um, I'll think harder in the future on to make something better. Um, what did I learn in this video? I learned a little bit, but it wasn't rich learning, you know? It's sort of like casual ingestion of information, you know. I'm fine. I'm seeing that, like, our faithful reproduction is not fully faithful as it needs to be. Um I know that I want better documentation. So that's something that'll be very important for me to keep in mind. Um I already knew how agents, you know what I mean, how like the supervisor works, and I already knew we were renting a box, you know what I mean, all that kind of stuff. So that wasn't really new information for me. Um and I knew about the what's it called? I'm very what's it called? If you noticed my reaction, I'm very happy that we trained a model from scratch. That was important for me. Um, yeah, I think we're pushing towards read the real paper. We're 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 moving towards leave the vibes. The vibes have finished. You know, um, no more AI. I have code that I've run and can rerun. Presumably, that's how that would work. You know what I mean? Um, I could be completely off on that premise. I've sort of been telling myself like, well, if this is able to run it, there's levels to it. You know what I mean? There's like the researchers were able to reproduce it or were able to produce it, and then they put their how to reproduce it publicly. That's one thing, but I'm pretty sure that's not trivial. You know, um, agent tries to do it, stumbles, fails a good while. Um, Pretty smart agents. You know what I mean? They're pretty smart. So I don't know if it's just like a gap or if I'm not giving it enough context, but I said faithful reproduction. It should have the access it needs. Unknown. We're gonna find out when I try to really go into it. But presumably, the fact that the agent's done it and I have that code, our reproduction is not the exact same as theirs. You know, um, even though they're trying to make it easier, we're gonna find these things out. So, um, that's what I want to do soon. I don't know how to make that a YouTube video. So I'll say part of what I want to do tonight, my homework for myself tonight is to, I don't know if you're hearing my stomach growl. I'm very hungry. Um, yeah, part of my homework tonight is to think of, wow, what would be really good both for me and for the channel. That's like 5 stomach growls. I don't know if the mic is catching that, but like I really need to eat. I don't think I've this is a record for me. This is a lifetime record for me. So, um yeah, just an all right video. I know I really like the transformer video. That was a lot of fun for me. Um, so maybe when I get into trying to reproduce the paper, me trying to explain my understandings of that, that'll be future videos. But those are quite long. Um, so yeah, I'll call it there. Um, have a good night. This is going up. Hopefully, I'll fix Vault Chat soon, and I'll be a little more. I'll be less stressed, I guess. I don't like that it's not working. So hopefully we take care of that. And next week is strong. By next week, ooh, I'm excited. By next week, we should be getting into it. You know what I mean? We should be doing some like real. It's my turn. You know what I mean? It's like, okay, Volchat's done. It's like my turn to really see both what I understand and like to like try to like reproduce it and stuff. Because just like again, last tangent. Like for example, like we're using GPT-2. Okay, so that means what's it called? It already exists. It's open source. It already exists. There's nothing that what's it called? I'm not building that from scratch. You know what I mean? And maybe that's what practical research is for large language models. Um, it's like this is just about the latent space reasoning. You know what I mean? Is it's just it's an architecture. It's a design thing, but that doesn't mean you have to. You can train the model from scratch, but it doesn't mean you have to build a model from scratch. You know what I mean? Like our goal isn't to try a new position embedding solution, and I don't know. I guess for whatever reason, if they try to do it from scratch, you know, a few things. It introduces unnecessary variability in the sense that they're doing this publicly for other researchers. You know what I mean? It's like, okay, maybe they're fully capable of doing it from scratch, but why are we giving ourselves more overhead? I think that's why like GPT-2 and like Llama 3 are standard. And I would almost say like I'm curious why they use GPT-2. It must have been before Llama 3 or something. I think it may be just too early of 2022 or 2024 or something. I don't know. But yeah, that's our video today. Have a good one.